Hi, everybody. I hope you had a good break. I know I did. It was my 26th birthday, so that was exciting. It actually fell on Labor Day this year, so that was interesting. Today we are going to do the pepper surface tension experiment. You can find this on the Google Classroom. It gives you several ways that you can produce your lab report. Just pick one of those ways or do it the way that you're used to. It's up to you. There is a word bank in there, and Killian and I were having a fun time trying to put the words together to make a long sentence that makes sense. So see if you can come up with the longest sentence that makes sense with that word bank. All right. I am not going to pull it up on the computer because it makes the video smaller and I want you to be able to see the experiment. So I just printed out the experiment sheet that I needed. Okay, so our materials needed are a small bowl. I got a large bowl so that way you could see. It doesn't matter the size of the bowl. I'm quite certain we're going to find that out, but I'm pretty sure it doesn't matter the size of the bowl. Fill that bowl, I would say at least halfway full with water. Then you're going to need pepper. It can be grounded, like the pepper you have to grind, or it can be grounded pepper. Either way, it will still work. If it is the pepper that you have to grind, it still has to be ground, though. You can't just have the balls of pepper and put them on there. Okay. We need a toothpick. There's a piece of popcorn in my other supplies. Dish soap. It does not matter what dish soap. It can be Palmolive. I don't know how to say that. Dawn or Gain, any of those will work. It just has to be dish soap, not hand soap. And I am adding something small, like a small plate, or I'm using a cupcake holder, just something that we can put our dish soap into to dip the toothpick in. Okay, so let's get started. It says fill the bowl with at least an inch of water. All right, I already did that here. I'm going to turn you down now so you can see. There we go. All right. Sprinkle pepper into the bowl of water. It will float. Okay. Most of it is floating. I do see a couple pieces that fell in, and I think that was just because they were thicker with the way it was ground. Okay, dip a toothpick into liquid dish soap. You can tilt the bottle or pour a small amount into a clean dish. So I'm going to pour just a little bit and dip my toothpick in. Okay. Now I have it on my toothpick. Dip the end of the soapy toothpick gently into the center of the dish of pepper. The pepper will scatter to the sides of the dish. Okay. Woo! You can see that they are slowly starting to all fall in at the sides of the dish. Okay, so why does this happen? Well, pepper is hydrophobic. What that means is hydro means water and phobic means not liking. So that word hydrophobic means does not like water, or the water is not attracted to it. So this is why it does not dissolve in water. The flakes float on top of the water because water molecules stick together and cause surface tension, a type of skin over the water. So surface tension, we could pretend is like a layer of skin over the water. That's what it's saying. Or if you want to imagine it as like a layer of saran wrap on the top of the surface. Pepper is so light it is able to float on the skin of the water. Soap breaks down the surface tension of the water, making it a great choice for cleaning, because when it's broken down that surface tension, then our grime can finally come off and rinse down the sink. Okay. As the surface tension breaks, the water tries to maintain a surface tension away from the soap, taking the pepper flakes along with it. Okay, so that explains why our pieces in the beginning fell to the bottom, is because they were too heavy. They already weighed too much that they couldn't float on the surface, that they broke that skin and fell in. All right, that is our pepper surface tension experiment. Now you want to go to your lab report and write Okay, you want to go to your lab report and write up if your prediction that you should have done at the beginning of the video or before the video started, if it held true or followed what you expected. You don't want to say that you were correct, because there is no correct in science. If you were to say you were correct, that means that if you didn't predict, or your expected results were not what you predicted, then you would be incorrect. And that's just not true. That's part of testing and why we do science experiments. So we can see what goes on and make adjustments to our predictions and testing, and then we redo the experiment, and that's the whole part of the scientific method. So you don't want to say that you were correct or incorrect or those are the two, or wrong. That's what I was looking for. You weren't wrong. You just didn't, your predictions didn't match the expected results or the results that were there. What else? You should also follow the lab report that is to your level. So there are several there. There is also another one in the No Topic Materials section at the very top of Google Classroom, and that can help you write your lab report too. It's important to write a lab report so that way we can redo this experiment over and over and over and so can other scientists. So if you were to give this experiment sheet to a friend, they should be able to do it the exact same way and get the exact same results. So that is why it is important to do lab reports. And we also want to make sure we are using scientific language like surface tension. And if you're at a higher level, I would expect you to use the word hydrophobic. We just learned that word today. And those things are very important when we are putting in a lab reports, so that way we don't have multiple words like me in this video. And so it makes sense to a wide variety of people. All right, that's all for now. See you guys next time.